Hi, I'm Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast, the week starting Sunday, June 21st. Tonight we'll be discussing jet stream roller winds, surface level pressure, significant wave heights, and all the things that go into making surf in the North Pacific Ocean. Let's get to work. Looking at significant wave heights for the South Pacific Ocean, we're in pretty good shape. We see a gale pushing under New Zealand, producing 34-foot seas, maybe 35-foot seas, aimed off to the northeast. And this is generating swell, pushing north, and is not the first one. There's one before this too, and there's yet another one on the way to California. So, we're not in horrible shape. None of them huge, but hey, it's better than nothing. Alright, let's start digging into the details. As usual, we'll start by looking at jet stream level winds. These winds of about 30,000 feet help support the formation of gales when they form, help direct their track. We're looking for a trough. That is a push in the southern branch of the jet stream pushing off to the north, just like this here. That is a broad trough being fed by up to 140 knot winds, not too bad. What that helps do is create a clockwise flow aloft and down at the ocean surface. And of course, clockwise flow in the southern hemisphere is a hallmark of low pressure. Low pressure, if it's strong enough, generates winds. Winds, if they're strong enough, generate seas. Seas, if they're large enough and radiate away, as they radiate away from the fetch area, turn into swell. And swell, of course, when it hits your beach, turns into surf. So a trough is the start of the process, and a trough being fed by decent or strong enough winds. That's exactly what we have here. And we know from looking at the wave model chart just a second ago, there are seas in this area. Let's put this into motion. So we get into Monday, the trough actually gets a little bit more energy pushing up into it, but not quite as broad as it was, a little less expansive, and then fading as we get into Tuesday, and basically gone with a very weak flow, zonal flow. That is a flow in the southern branch running from west to east. No particular swell production potential, but then we get into Wednesday, and another trough materializes, this one with 150 knot winds pushing off to the north. Kind of pinched, kind of short-lived, but hey, it might generate something, and pushing further off to the north than the previous trough. A little bit more of a northward trajectory to it. That's good for pushing swell up into the northern hemisphere, which is exactly what we want. By Thursday, that trough starts fading out. Maybe a little bit. There was some of the models suggested something going on in this secondary pinch trough on Saturday, but we're thinking probably not. And then as we get into Sunday, the southern branch pretty much gets very weak and just not a whole lot forecast happening. And there we are, 180 hours out. But the good news in this is at least you don't have some big ridge. There's a ridge there pushing south. That would completely shut off storm production. So this is at least moderately encouraging that if you're not going to have a storm, at least you don't have something actively shutting storm production potential down. All right, let's move on. Take a look at surface level pressure and surface level winds. And here we are. Here's New Zealand here. There's a fetch of 45 knot winds right there, the red, 45 to 50 knots. Small area, south of New Zealand, but embedded in a broader area of 40 knot and even yet a broader area of 35 knot southwest winds, aimed off to the northeast pretty good. That's capable of generating some swell. Also notice, where is Tahiti? Tahiti's like down right around in here. Low pressure has been passing over that area. You can see it here. When we get into the Southern Oscillation Index discussion, you'll notice it's very negative. That is why. Anyway, moving on, we get into Sunday night. Winds actually build, tiny area, 50 knot winds. That's good for producing seas. And into Monday, still 45 knot and almost due out of the south. Actually, we'll call it southwest, but aimed pretty well to the north. That's good for pushing swell up in this direction towards Hawaii and California. Right, that system pretty much fades out. Notice this tropical low is falling south, of no real interest. And then we get another little system come Wednesday starting to develop south of New Zealand, 35, barely 40 knot winds, but out of the south. That's good for Hawaii. And building, broader area as we get into Wednesday night, but nothing exceeding 35 knots. So that's You know, you really need 40-knot winds to get you 30-foot seas, and that's kind of the minimum threshold. Then this thing tries to develop again as we get into Thursday night, but this part of the low actually is falling south. Oh, and there's yet another one also north of that, but it's only producing north winds and for the most part falling south as well. Nothing really to come of that. And then we're rolling out. Where are we? We're on Sunday now. Theoretically, cutoff low here Sunday, maybe producing 40-knot north winds. Maybe some hope from that, but it's 180 hours out. So we'll just go what's for sure for sure. All right, so let's go take a look at the effect of those winds on the ocean surface. But first off, we're going to go back in time just a little bit. So we're Friday. What is that? Maybe 3 days ago, 2 days ago. A small gale, we'll call it more of a primer gale, pushed under New Zealand, generated 31-foot seas, 32-foot on Friday evening, and then continued almost, it fell south a little bit with 33-foot seas on Saturday morning, then started pushing off to the east with 35 and then 37-foot seas, but really it's the northward trajectory you want to see, not an eastward trajectory. That's what pushes swell energy to the north. Still, some sideband swell is expected. Then on Sunday morning, a secondary gale, really the main event, started developing south of New Zealand with 33-foot seas and then pushing almost 34 feet as of right now. Let's go take a look at the forecast. And here we go. All right, moving into Sunday night, fetch getting much stronger. Broader area of now 37-foot seas, building to 41 feet about 11 p.m. tonight, and then holding in the 41-foot range. Supposedly, that looks more like about 39 feet, but maybe 41 feet over one tiny little area, and then fading, but still pushing off to the northeast pretty good. That certainly should be capable of generating swell radiating north. Take about a week to get to Hawaii, and maybe 9 days or so into the U.S. West Coast. Then things fade. Another gale on Wednesday. We saw the fetch earlier, generating 28, 29-foot seas, something like that, and lifting off to the northeast. Is probably good, certainly good for Tahiti, good for Hawaii, and bare minimal. I mean, what is this, 29-foot seas? So that's good for 15, 16-second period swell for California. So, something better than nothing, but not nearly as much as what we saw with the last system. Then we know we have a series of gales stacked up over here, most of them falling south, not generating any real seas of interest. Now, here we go. Sunday, this is a week from now, tiny area of 30-foot seas, lifting northeast 32-foot, and the Southern California swell window ends over here at about 118 west. So, maybe something could come from that, and that's the end of the model run. That's a week out. We're not really going to believe it, but something to monitor. Now let's go take a look and see wind swell-wise if there's anything that's of interest. So right now, high pressure, 1024 millibar, not very strong, in the typical position for this summer, generating northwest winds at 15 to 20 knots, mainly along the northern California coast and just off the central California coast. Good for small, short period wind swell, but nothing of real interest. And 15-knot winds off, so high pressure rotates clockwise in the northern hemisphere. Heat inland creates sort of like a low pressure system. The gradient, the difference in pressure between the two tightens up these isobars like right there and generates wind. Then we also have easterly fetch coming around the south side of the high, generating some minimal trade wind swell pushing into the east shores of exposed breaks on the Hawaiian Islands. So we get into Monday, the high starts ridging or pushing inland into Washington, tightening up the gradient here. 20-25 knot northwest winds off of Cape Mendocino in Northern California, generating maybe some larger wind swell. In these situations, it's mainly, I'll say, somewhere from Big Sur northward, something like that. Really steep north angle, doesn't get into everywhere. Better for Northern California. Anyway, and the fetch evaporates off of Hawaii. So Monday, wind swell. Tuesday, more of the same, not quite as strong a fetch, but then it starts building Tuesday night off of Cape Mendocino in Northern California. And notice easterly fetch east of the Hawaiian Islands starts building as well. So we get into Wednesday, wind swell again for California, north of Point Conception, and the Hawaiian Islands. And here you go, some sort of a tropical system suggested. We'll see if we can keep this in the frame here. There we go. All right, we'll move forward. Not sure if we really believe that, but good wind swell. as we get into Thursday for Northern California, and still wind swell for the Hawaiian Islands. And then Thursday night, Friday, here we go, 35-knot winds off Northern California, east trades for the Hawaiian Islands, more wind swell. Now we're into Saturday morning, more of the same. Tropical system fades out, high pressure starts evaporating relative to Hawaii, 1032 millibar high, centered a little bit further north of Hawaii. Notice here's where all the fetch is, so probably not a whole lot for Hawaii. Then we get into Sunday. Look at this broad area of 35 knot north winds, not over a huge area, but certainly capable of generating wind swell for north and central California and the eddy flow, south winds along the coast here. Remember, this is low pressure rotating counterclockwise here, heat low pretty much, and the further that moves out into the ocean, the stronger the south winds get along the coast north of Point Conception. And we're out on Sunday, and then Sunday night, more of the same. So wind swell, reasonable for California, but definitely building as we get into next weekend, and then fading out for the Hawaiian Islands. No chance for precipitation. We're not even going to go look there. It's summertime relative to California, so that's just off the charts. All right, let's go take a look long term. What's going on with the Madden Julian oscillation, that periodic weather oscillation that travels from west to east on the equator the whole way around in the planet? When in the active state, which is the equivalent of low pressure, it helps feed energy into the jet stream, which in turn helps produce storms. And then when in the inactive state, basically does the opposite, produces high pressure, suppresses storm production, or at least makes them less likely to form and not so good for surf production and or weather production. Then, of course, our usual look at El Nino or La Nina, try to figure out where we're headed, though it seems pretty obvious. All right, so first up, the MJO discussion. What we're looking for is the presence of the active phase of the MJO, and the first way we do that is looking at winds on the equator. So this is data from the TAO buoy array, series of buoys strung across the equator. This is the East Pacific here. This is the West Pacific here. There's New Guinea. That is the equator, 0 degrees. 180 is the date line, international date line. All right, and we're just looking at the arrows. The colors are water temperatures. We're not so concerned with that at the moment. Okay, winds are from the east, pretty strong, long arrows, pretty strong east trade winds. That's typical this time of year. But notice they get weaker as we get into the West Pacific, what we call the Kelvin Wave generation area. This area from the far West Pacific is actually about 135 west to about 170 west, just over the date line. I'm sorry, 135 east to 170 west. 5 degrees north and south of the equator. Just this one little box here. But if you get a strong active phase in here and you get westerly winds or even strong westerly anomalies, it can take warm water that's here, start pushing it off to the east, and creates what's known as a Kelvin wave, a ball of warm water that travels under the equator from west to east the whole way across the Pacific, takes 3 months, and then can erupt off of Ecuador. If you get successive active phases of the MJO and they're strong enough, you get successive Kelvin waves, and that can help kick off El Nino, but we don't think we're anywhere near that right now. All right, looking at anomalies. So we see bunches of winds, but the winds vary from not so much from day to day, trade winds on the equator, but from the time of year, right? So anomalies, are these winds stronger than normal for this time of year or not? Well, we look at the arrows again, and they go just 5 degrees north and south of the equator, maybe a little bit stronger out of the east based on that one arrow and maybe one little arrow there. But you get into the central Pacific, pretty much normal. And then what's more interesting, you get into the West Pacific in the Kelvin wave generation area here. You see arrows out of the west. That suggests maybe a weak version of the active phase of the MJO with weak west anomalies. Are we going to get a Kelvin wave? Probably not, but we'll keep digging. All right, so what's the forecast for the next 7 days and sort of what has been going on in the Kelvin wave generation area for the past month, right? So this is the east-west component of the wind. We don't care about north or south. If you have west winds, that creates Kelvin waves. If you have east winds, that pretty much stomps on them and doesn't help support storm production in the upper levels of the atmosphere, and specifically in the Kelvin wave generation area. All right, so this is the whole plan on one chart. 180 is the date line. Kelvin wave generation area starts about 135 east, so from about here to about 170 west, right there. All right, and you can see what's going on here pretty clearly. In the very far west Kelvin wave generation area, the blue is westerly anomalies. The yellow, is easterly anomalies. The yellow is westerly anomalies. So it sort of looks like a hybrid of this would be active phase of the MJO, inactive phase of the MJO. But you see these westerly anomalies, if they were the MJO, they'd be going from this side of the chart to this side of the chart, and they're not doing that. They're just sort of an anomaly that's here for the moment. And what we do see is easterly anomalies have been in play in the Kelvin Wave generation area for pretty much the whole month of May into June, and are forecast to build pretty strong starting about 3 days from now, filling the Kelvin Wave generation area. And then if you look here, going, California's at 120 west roughly, almost the whole way to the California coast on the equator. That does not bode well for storm production. All right, a little bit further out. This goes 2 weeks out. This is a different component of the MJO. This is outgoing long wave radiation, OLR. Where is it on here? OLR. All right. Fancy words for cloud cover, right? If you have the active phase of the MJO, which is the phase that helps support storm production, well, that's like it's basically like a low pressure system, and therefore you'd have clouds associated with it. The blue is the active phase of the MJO. It's in the Indian Ocean. The yellows and oranges are lots of clear skies, no cloud cover. Equivalent to high pressure, that would be the inactive phase of the MJO. So according to this model, statistic model, today, inactive phase of the MJO, and we know we have a little bit of westerly winds, but they're not supposed to last but for a day or two. Same thing 5 days from now, and then the inactive phase fades out 10 days from now, and supposedly a weak version of the active phase moves into the Kelvin Wave generation area 15 days from now. That's according to the statistic model. But the dynamic model, not quite as favorable. We saw this last week too, where it is unchanged from last week. Just inactive phase, inactive phase, inactive phase, stronger inactive phase 2 weeks from now. So let's see if we can cue this up. We can get both the last frame of both models. So the dynamic model says inactive phase building. The statistic model says active phase weekly building. So they're at opposite ends of the spectrum 2 weeks from now. All right, let's dig more. Phase diagram charts. All right, this is another way to track the MJO, a better way to track the strength of it and its exact position. So what are we looking at here? This circle, assume this is the North Pole, and you're looking down. If this is the planet, you're looking down from the top, down towards the North Pole, and the equator is out around the edges here, and the MJO travels from west to east around the equator, all right, like this, from the Indian Ocean over the maritime continent, over the West Pacific, East Pacific, under the United States on the equator, across the Atlantic, over North Africa, back to the Indian Ocean. The heavy dot, which is right here, is where the active phase is today. So we'll say in the western Indian Ocean, the closer that dot is to this circle, the weaker it is. The further out here it is, the stronger it is. And these are the different members of the statistic model suggesting the forecast track, all of which suggests a very weak active phase, pretty quickly moving to the West Pacific, but exceedingly weak, if not even non-existent at all. So no real help there. The dynamic model, not even any better. If anything, it says the active phase is to retrograde, go backwards over like North Africa and just hang out there and be very weak. So effectively, no MJO signal at all forecast for the next 2 weeks. That's not good for producing westerly wind bursts or Kelvin waves or anything like that. Okay, the upper level model. So this is a precipitation model. Areas favorable for precipitation. Yellows and oranges, not favorable. Dry conditions, which would be equated to the inactive phase of the MJO. So you can see South America there, Central America. This is the equator. There's New Guinea. Okay, so inactive phase of the MJO forecast, and these are in 5-day increments, working its way across the Pacific, pushing into Central America on the equator about the 16th of July. And then the active phase supposedly starting to build in the West Pacific, we'll say around the 4th of July, and then using the whole month of July to make its way across the Pacific. So July would be a good month, at least according to this model. If you're looking for surf, July, theoretically, per the upper level models, is your goal. And then late in July, another inactive phase develops and pushes off to the east. a 1 month model. This is 850 millibar winds, wind speeds, again, that east-west component of the wind. And notice each one of these models goes out a little bit further, therefore less, you can't believe it as much that far out, but it helps build a picture, build some correlation between the models, try to build an image in your mind of what's going on. So today, let's see, okay, where are we? Far west Pacific is 135 east, about right there. And then the far, the east Kelvin wave, the date line right there. So we'll cut it off there. This area right in here is what we're looking at. This is the forecast going forward, July 20th, yesterday. Notice this is what is this red thing? Equatorial Rossby wave, ER. That's what's generating the small patch of westerly winds on the equator over near the date line today. That's supposed to be gone in about 2 days. And notice this. Easterly anomalies. The blues are easterly anomalies taking over. No MJO signal at all forecast. We're just at the whims of whatever happens. This dotted purple line is the, what do we call it? The low pass filter right there. And when you see dotted lines that in the purple, typically means a high pressure bias. All last winter, I don't know if no, you can't see it on here, but all last winter we had a low pressure bias. I think actually for a couple of years we've had a low pressure bias over the Kelvin wave generation area, sort of like a, not quite El Nino, but something that has a tendency, a bias towards El Nino. That's not the case. If anything, this high pressure bias suggests a developing La Nina pattern. Keep that in mind. So here we go again, whole planet on one chart. This model goes out, this is the CFS model, goes out 3 months, right? Upper level model, Kelvin wave generation area starts here, so you just go the whole way up here, and the date line right there at 180. So the far east side of the Kelvin wave generation area, 170 west, so right up through there. Okay, and the forecast is up here. This is what's been happening in the past. So here's where we are today. Here's our little bit of easterly anomalies in the far west Kelvin wave, a little bit of westerly anomalies in the on the date line. But then you look up from here. Actually, this is the best we've seen it in a couple of weeks now. Easterly anomalies non-stop, a little tiny patch of westerly anomalies building in September. Let's overlay the MJO here. All right, so the dotted line is the inactive phase of the MJO. Consider it like high pressure. See, inactive phase of the MJO in control. Active phase tries to organize, doesn't even make it to the Kelvin wave generation, fades out. So inactive phase the whole way into the end of July, supposedly. And then the active phase sets up, but it's very weak. Not even really any westerly anomalies in the Kelvin wave generation area. And then a secondary active phase, supposedly in September, builds some westerly anomalies, but still large area westerly anomalies in control. Now we're going to overlay the low pass filter. This is that high pressure, low pressure bias. Here's last year. Actually, this is March. This is this year. This is the low pressure bias in control. It just died, and here was the high pressure bias in the Indian Ocean, and they were sort of in a drought blocking burning pattern in Australia. Now notice where the high pressure bias is moving to the Pacific, and strengthening with 2 contours here. It's already in control, supposed to build by August 6th to 2 contours. And the low pressure bias that was over the Kelvin wave generation area is now forecast to move to the Indian Ocean. This is the typical La Nina type signature. This model has been projecting this. NOAA is not going along with it. Their latest forecast said basically, 50% chance of neutral El Nino pattern as we get into the fall. This model doesn't agree with that. This model and two other dynamic models are basically singing the same song, but a whole bunch of the other models are not going along with this. So there's a bit of a discouragement or a bit of a disconnect between the models. But it's really what's going on at the ocean surface, I think, that will set the tone completely, and we'll get into that in a second. All right, so what is going on in the ocean, all right? We've talked about the MJO and that sort of thing. We've talked about high and low pressure biases and that. But the ocean, it's the El Nino, La Nina is a coupling of the ocean and the atmosphere. Not one alone makes a difference. So we got to start digging into the ocean. So what are we looking at here? Subsurface temperature data. This is the ocean's surface. This is in the Pacific, only on the equator from 2 south to 2 north. This is the East Pacific here. This is the West Pacific. And These little squiggly X's going down here are the anchor lines on the TAO buoy array, a series of buoys. So there's like a couple of buoys here, a couple of buoys here, and they have anchor lines going whole way down to the oceans, down to the bottom of the ocean. They stuck sensors on those anchor lines so they could get temperature measurements, and that data is relayed via the buoys up to satellites. It goes to somewhere in Virginia, I think, or Maryland, and then they compute it all, use a model, and try to connect the dots and fill in the difference so you can get a look at what subsurface ocean temperatures are doing. These are in centigrade now. So this is the 30-degree isotherm line here. This is warm water. It's all in the far west Pacific. It's at 163 east. That's about where it was. I think it was maybe 162 east last week, so it hadn't changed a whole lot. The 29-degree isotherm at 170, I think it was hanging about 175, so it's actually made a little eastward progress. Remember, Kelvin waves are warm water traveling from west to east under the equator. So if a Kelvin wave was in flight, you'd see these lines starting to push off to the east. Okay, they're not really doing that. The 28-degree isotherm at 156, I think it might. At one point, it made it over to 150 west a couple days ago. Backtracking a little bit. 24-degree isotherm a month or so ago it was pushing into Ecuador. It's backtracked. It's been hanging in between about 120 and 125 west. That's a point south of California on the equator. So no real change here. That's the actual temperatures, but it's the anomalies, differences from normal for this time of year. And what's this telling us? Well, it's telling us that temperatures are zero, about neutral here in the West Pacific. Maybe pockets, maybe 1 degree warmer than normal. But we have this 2 degrees below, minus 2 degrees centigrade. That's like 5+ degrees Fahrenheit. And a 3 degree centigrade negative right here in the East Pacific, and these guys are all connected. You almost get the sense there's a flow of cold water starting here and just filling the entire easterly Pacific. This is typically what happens during La Nina development. This is the exact opposite of what you want to see. You want to see warm water forming in pockets like this and traversing into the East Pacific. Instead, what we think we have going on is stronger than normal trades here, cutting off the flow of warm water to the east, and instead you get colder than normal anomalies. And here's another model, a little higher, more fidelity model. We got 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 5 degrees below normal. What's that? That's almost like 10 degrees Fahrenheit colder than normal here down at depth, off of Ecuador and reaching to a point. Well, Hawaii's at 155 west, so you get the idea. The entire equatorial Pacific colder than normal as of June 17th. Satellite data basically giving us the same picture. So this is South America here. Kind of weird to look at. It's not quite, it seems like it's stretched a little. Central America, Mexico there. There's Florida, Baja, Hawaii right there. There's the date line. There's the equator. New Guinea right there. All right, so what are we looking at? Minus 10, that's not minus 10 degrees, minus 15, that is so this is the height of the ocean, okay? And what this is saying is that the ocean is lower than normal over this entire expanse. Well, how could it be lower than normal? Well, if the trades are blowing harder than normal and you have cold water at depth, what it does is takes warm water that's normally here, pushes it all off over here. Notice you have positive anomalies here. Okay, so then you get a buildup in the West Pacific and you get a depression in the East Pacific. And if you have cold water depth, that cool pool that's here, cold water contracts a little. That enhances the divot on the ocean's surface, so you get cool anomalies. And all this sort of does is say, you got a lot of cold water. This definitely looks like a typical La Nina kind of setup. And if anything, it's building in coverage, not getting smaller. Here's the trend over the past year. This is the West Pacific here, East Pacific here. This is water temperatures back in July. So you see this was a Kelvin wave that stalled. It was produced by the active phase of the MJO last June or so. Westerly winds blew, took warm water here, pushed it off to the east, but it stalled, made no real progress. We got this cool pool, like a false start La Nina last summer, and that really is what messed up our whole winter. Okay, once you get cold water in the East Pacific, it kind of just messes with the jet stream and makes it so it doesn't want to push storms towards California, towards the U.S. West Coast. That just so things are drier than normal. I think we were 50% snowfall and rainfall for California this year, and it also messes with the jet stream. It splits the jet stream and makes it so storms don't push towards California. Okay, but then we got lucky. In September, we got a westerly wind burst. Active phase of the MJO produced a small Kelvin wave that made its way into Ecuador. And then another false start one in like the November-December time frame, but couldn't really push hard into Ecuador. And then in April, it just all shut down. You see this building cold water at depth just taking over. So if this was the false start La Nina last year, this looks much stronger. If this false start cool pool last summer really shut down our winter last winter, I wonder what something that's like twice as strong now is going to do come this coming winter. So just keep that in your mind. All right, what's going on at the ocean surface? Enough of at depth. I mean, though we think we had a pretty good handle on it, this is pretty obvious. From last week, not a whole lot of change. So the yellows are warmer than normal temperatures, the blues colder than normal, and it's only what's going on the equator, 5 degrees north and south of the equator. So from about here down to about here, or what is that, 0? I think that's 20, so it's, yeah, right in there. So you can see colder than normal water, developing off of Peru, making it up to Ecuador, over the Galapagos, and on out to almost the dateline. And this is June, the end of June. This is typical how La Nina starts. This is almost on track. I think we showed it last week of comparing this year to the last La Nina, which was in 2018, and this is almost a mirror image of it. So no big surprise there, no big change. If anything, maybe this is backed off just a shade from last week, but not significantly, and that's due to that little pocket of westerly anomalies that we saw in the Kelvin Wave generation area. That's just stomping on trades ever so slightly, but we know by looking at the models that we're in for an easterly wind bout that's going to go for at least the next month. That will probably only feed the development of this cool stream here. So here is the trend for the past 7 days. The blues are areas that are getting colder. The reds are areas that are getting warmer. We only care about on the equator, 5 degrees north and south of the equator. So what this says, now this is not absolute temperatures. That's actual absolute temperatures as compared to normal. This is just for the past 7 days. And what this suggests is that, yes, in fact, the cooling that has been here has sort of backed off the past 7 days. We actually have some warming going on, but that doesn't mean that it is warm here. It's just mean the cooling isn't getting as cool as it was. It's sort of like a pause in the trend. So something to be hopeful for, but where are we going to end up? Unknown. But again, here's the backed off view. Cool tongue, everything is driven by what's going on in the equator. Officially, the El Nino monitoring region is from 120 west to 170 west, 5 degrees north and south of the equator right here. This is the Nino 1.2 region here. It's a noisy area. You can kind of get to me. This Nino 1.2 area is your rainfall indicator for California. You have blues all in here. That's a pretty good indicator. If you have cooler normal temperatures, that means you're going to get high pressure setting up north and south of that, and that blocks rainfall in California in winter months. And if this is building and going to continue on into the fall, that gives you a hint of what is to come. This thing doesn't typically mature, either La Nina or El Nino, till the December time frame. But when you get this sort of signature in June into July, sometimes it'll disappear, but everything we're seeing says that's a minority chance of that happening as of right now. And here's one other view, basically the same picture. Yeah, you see warming all up and around here, but it's what's going on in the equator that seems to really matter. If you have and typically, so there's high pressure here, it rotates clockwise in the northern hemisphere, counterclockwise in the southern hemisphere. If the two of these are stronger than normal, remember they're flowing like this. This guy's flowing like this. That means you get stronger than normal trades here. You get this upwelling pattern. You get cold water. And when that happens, that's classic La Nina kind of signal. So we have one other bit of data. We haven't shown this before, but this is the Equatorial Currents. This data used to be available. We had a real hard time finding it. We finally found a site that does it. Okay, so you can see there's a current here, but what you can't really see is what direction it's going. So we'll zoom in, and there you go. You can see the current flowing for the most part from east to west the whole way across the equator, okay, which suggests trades are blowing harder than normal. You've got that upwelling. No wonder there's upwelling, because all the warm water is being pushed off in this direction. During an El Nino flow, you get the exact opposite. You'll see this current reverse, and you'll see the arrows going from west to east, which typically is the enabler or the conveyor belt to take warm water from the west and push it off to the east. We've got the opposite going on. So all this is really telling us is, yeah, ocean, everything in the ocean is telling us La Nina. The atmosphere, we haven't got there yet. But from an MJO perspective, the MJO is dead. There's no active phases, really. Even when they do happen, they don't produce west anomalies. There's no west anomalies. There's not even really that much warm water over in the far west Pacific. So even if you did have an active phase, the MJO, it just, there's nothing for it to do to try to warm up equatorial temperatures. The ocean has basically done its thing. It's just like tapped out. There's no more warm water to push around. So that's how you fall into a La Nina type flow. Now, what does the atmosphere think is going on? We talked about the deep in the ocean. We talked about the ocean surface. We talked about the currents. We've talked about the MJO and what's going on with this, but, just at a macro level, what's the atmosphere think is happening? Well, difference in pressure between Darwin, Australia, and Tahiti is how you do that. Southern Oscillation Index, they call it. When pressure is lower over Tahiti, you get a negative index. Daily numbers, look at this, minus 32. That's really strongly negative. But that's a fleeting sort of thing, because we saw in earlier pictures there's low pressure sitting over top of Tahiti. So, of course, the index is going to be negative. And you can see there was another tropical low pressure here too. But in general, the numbers, they've been kind of negative lately. 30-day average takes some of the noise out of it. So where was it? It was positive at 2, and it's been dropping negative. We're down to minus 8.82. That's good news. I mean, that suggests the active phase of the MJO at least. But we know that, in fact, that's not happening. There's literally no data, no modeling, no objective evidence that the active phase of the MJO is even present or doing anything in terms of creating westerly wind anomalies. And then the 90-day average is your El Nino La Nina indicator, yet a longer-term trend. It was minus 1.2, something like that. It's basically dead neutral. It's been dropping lately because of these two tropical systems, but we expect that will fade. I mean, hey, we could be surprised. There could be a whole string of tropical systems, and, but I'm just going to say, if you were going to have an El Nino, you would know it by now. There'd be all kinds of indicators pointing in that direction, and everything is pointing towards La Nina. The only thing that isn't is the fact that you've had two tropical systems, that they've pushed the index a little bit to the negative, but that is a minority report as of right now. All right, and the 30-day Southern Oscillation Index on a chart. So when you're up in this range, positive, that's La Nina. When you're down here, that's negative range. These downward spikes are the active phase of the MJO. The active spikes are the upward spikes are the inactive phase of the MJO. Right now, it looks like we're in a strong inactive phase of the MJO, but nothing else suggests that other than this one index, and we think that's all being driven by tropical low pressure systems that just happen to be pushing directly over Tahiti. Okay, great. Driving the index negative, but prior to that, you could see the trend was since July of last year has been steadily upward. We expect at any point in time, like in the next week, as those easterly anomalies get really entrenched over the Kelvin Wave generation area, that this is going to make a departure and start heading positive. How positive it gets, unknown. Let's take a look and see what the CFS model says. CFS models, sea surface temperature forecast for the Nino 3.4 region, the official El Nino monitoring region between 120 west and 170 west, 5 degrees north and south of the equator, on the equator again in the Pacific. All right, so what are we? We're end of June-ish. Temperatures officially, according to this, are 0.3 degrees below normal. Let's go see what they actually are. Nino 3.4 index, daily values, June 21st. Okay, minus 0.214, so the model overhyped it a little bit, but we were down at minus 0.4. Draw sort of an average through this latest bit in June, and it's about 0.3. So I'd say the model's pretty well on track, and you can see what the trend has been. It was warm last March, March, April, and then somewhere in late April, it's just been taking a dive. You see the results in the charts. Cold water over the equator. Barely hanging on at the moment at 0.214. All right, so let's see. Late June, 0.3 this says. Probably pretty close. Forecast, diving as we get into July, August, early September down to a degree below normal, maybe 1.1 degrees, and then holding there steady the whole way through the fall and into the beginning of winter, then coming out of it. All right, so you go, well, you need to be La Nina, you have to be at half a degree below normal for 5 consecutive months. So we'll say we'll say August, September, October, November, December. According to this, yeah, that would qualify for some sort of weak La Nina, but then recovering quickly. All right, you go, well, maybe that's not going to be officially a La Nina. And I'll say, okay, fair enough. But remember, last summer, it was colder than normal temperatures at like half the strength of what we have today. And what was last winter like? It was pretty much not good for surf, not good for skiing, not good for rainfall. And this winter is looking already twice as worse as last year. So, barring some miracle, some magical awakening of the MJO, which no model sees happening, and with everything saying all the energy is shifting to the Indian Ocean, I mean, I'm not trying to be Debbie Downer here or whatever you want to call it, but it certainly smells as if some flavor of La Nina is coming. All right, so let's put things in perspective. Just because La Nina is coming, that doesn't mean there isn't going to be surf. What it does mean, though, is that the probability for large surf, extended periods of large surf, and rainfall and snow are less likely in California during the winter and fall months. Doesn't mean there won't be surf. Just like now. Hey, we see storms. They're developing in the Pacific. But is this summer an epic summer? No. There's waves. There's been a couple of good days. There hasn't been anything great. There hasn't even been any what I call significant, maybe 1 or 2 significant class days of surf in California and Hawaii, but nothing huge. It's been rideable. Have fun. It's better than nothing. I'll take it. But in terms of managing my personal expectations, I'm thinking we're going to be in La Nina. I'm thinking that when there is surf, you better make the best of it. If you're trying to plan ski trips and just ignoring the whole COVID thing, typically what happens is the jet stream gets shunted off to the north. High pressure is locked down over California. If you're going to take trips, plan on going north, somewhere middle to North Oregon and further north than there. The jet stream could actually be pumping and driving massive amounts of precipitation that normally would be coming into California up there. So it could be epic, right? You just got to be flexible. If you have the data and you believe it and you think logically about what's going on, you can score, but you need to be smart about it and you need to be logical and you need to, plan a good strategy. If you can't do that, if you don't have the money to travel all that, sure, that doesn't mean that you're not going to have surf, and it doesn't mean there won't be snow, but when there is snow, when there is surf, you have to drop in everything and go make the best of it when you got it, because, that's the kind of year we think it's going to be. Anyway, so that's kind of it for right now. The good news is, hey, there's little southern hemiswell in the water. There's another one supposed to be hitting tomorrow in California. There's 2 systems. One of them supposedly getting pretty solid the next day or two, maybe a little bit more beyond that. So there's going to be surf. go get it when you can get the chance. Make the most of it. Have a good time and be thankful you're alive and in good health. That's what really matters, right? All right, so that's kind of it for this week. If you enjoyed the video, give us a thumbs up. We'd appreciate it. If you haven't subscribed, subscribe to get automatic notifications. If you don't subscribe, that's cool. Go to stormsurf.com. All this data is present there. You can look at this daily, weekly, whatever you want. And there's a whole bunch more that we haven't shown you. Links to the video will be posted there as well. Next week, we are not going to do the video. Going to take a little bit of a break. I mean, I think everyone kind of knows where we're going. You can go look at the site and figure this stuff out for 1 week. But the week after that, we'll be back. Happy to present the information. And hopefully there'll be a change in the more positive direction. All right, so that's it for this week. Thank you. We'll see you 2 weeks from now. Be safe and have fun.